So today we're going to be going over summation formulas. Now, these aren't anything special in the fact that we can't do these without doing a method via brute force. Like we can 100% go through this summation formula from 1 to 5 by plugging in 1, 2, 3, 4, and 5. The idea is we're getting comfortable with using certain abbreviations to make the formulas easier to use, with the end result being something that, albeit we could do it via brute force, going from 1 to 50 is going to be a little tedious. Going from 1 to 100 is going to be even more tedious. So we'd like to stick with as simple as possible to reduce the amount of work that we do. So without further ado, let's go ahead and jump into number 1. Now, if we look, number 1 is a sum from 1 to 5 of 6i plus 18. Now, the idea here being is that we can take a constant that is multiplied by a formula and pull it outside of the summation notation. So if I look at this formula right here, what I see is that this is going to be a sum of I equals 1 to 5 of 6 parentheses I plus 3. And now that 6 can be pulled outside of the notation. So I equals 1 to 5 of I plus 3. And we have 6 outside. Now, when I reduce that, that is going to be 6 times. And let's go ahead and write out every notation from 1 to 5. So I have 1, 2, 3, 4, and 5, all plus 3. And I'm multiplying 6 times this sum as opposed to 6 within that. And it just reduces the effort that we have to do. Now, we're going to kind of cheat just a little bit right here, and we're going to plug this in. We're going to say, okay, this is 4 plus 5 plus 6 plus 7 plus 8, and we get 30. So what we're dealing with right here is a 6 times a sum value of 30. Not sure what I was going for right there, but we're going to say that's a 30. And that is a total value of 180. Now, that works with both numbers and it works with variables. So if I see the fact that I have an n that is a common factor right here, I can rewrite this formula as what is the sum of I equals negative 2 to 2 of n, I'm actually going to do this in green so we can spot it a little easier, of I minus 4. We can easily pull that n to the outside. Let's set it up so we can see the first one there. If I pull the n to the outside, I'll have n times the sum of I equals negative 2, whatever I just drew there, to 2, of I minus 4. So now when I rewrite this, I'll have n times, starting with negative 2, negative 1, 0, 1, 2, all minus 4. And so that'll be negative 6. Let's break this out again. So we'll have negative 6 plus negative 5 plus negative 4, negative 3, and negative 2. N times negative 20, which will give us a grand total of negative 20n. There we go. So we see that if there is a constant in the function, it makes the work a little easier to pull that constant out. And we'll use this later on when we abbreviate it even further. The next shortcut that we're going to be doing is if I have multiple terms inside the brackets, like a 6i squared minus 4i, I'm allowed to break that into 2 summation rules. That being said, again, we can do this via brute force, but it's going to help us later on by splitting it into 2. So we're going to split this into a sum of I equals 1 to 5 of I squared, and we're immediately going to pull out the 6 minus 4 sum of I equals 1 to 5 of I. And now you might ask, okay, why did we pull out the 6 and why did we pull out the negative 4? Why aren't they included if it says the sum of A plus B is the sum of A plus the sum of B? Well, remember our previous step where we pull out any sort of constants. So I see that that coefficient of 6 is going to be pulled out. The 6 was with the I squared, and we immediately pulled it out. This allows us to say, okay, what is 6 times, I'm looking at numbers 1 through 5, so 1, 2, 3, 4, 5, all squared. And I'm summing all of them up. Minus 4 times the numbers 1, 2, 3, 4, and 5, all summed up, which is going to give us 6 times something minus 4 times something. And if we break this out, if we have a 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared will give us 55. 1 plus 2 plus 3 plus 4 plus 5 is going to be 15. And if we evaluate that all the way, this will give us a grand total of 6 times 55 minus 4 times 15. 270. Awesome. So now that we've kind of started getting the hang of this, why don't we go ahead and first pull out, either split it and then pull out the coefficient, or pull out the coefficient and then split it. Try out number 7 and number 9 using this rule right here. Pause the video, unpause it when you're done, and see how well you did. Okay, let's go ahead and take a closer look at number 7. So the first thing that I notice is that because these both have a factor of n, I'm going to do this slightly different than the way above. You're going to get to the same answer, but I'm going to pull out that factor of n. So I'm going to see that I have an n times the sum of I equals negative 4 to 0 of I plus 5. And so what I'll do right here is I'm going to split this sum into 2, but I have to keep n times that. So it's going to be n times the sum of I equals negative 4 to 0 of I plus sum of I equals negative 4 to 0 of 5. Now, it might be tempting to pull that 5 outside because it is a coefficient, but again, remember, I do not have any sort of value going on in here, so I'm going to have to count out that 5 several times. And then the last piece, to make sure that that n is distributed to both of these, because it's distributed to the whole sum formula, I'm going to put parentheses around that. So what I have is okay, n times negative 1, or negative 4, negative 3, negative 2, negative 1, and 0, plus negative 4, negative 3, negative 2, negative 1, and 0. Just a bunch of 5s going on right there. Awesome. So this sum right here is going to give us a grand total of, let's take a look, negative 4, negative 3, negative 10. So we have n negative 10 plus, and we have 1, 2, 3, 4, 5 5s, 2, 3, 4, 5, which is going to be 25. Negative 10 plus 25 is going to be 15, and that will be 15n. There we go. Okay. And if you tried the last one, number 9, let's go ahead and knock this one out. We know this one's going to be immediately split into 3 terms. I have the sum of 1 to 6 of I cubed plus the sum of 1 to 6 of I squared plus the sum of 1 to 6 of I. Now this is going to allow us to just go ahead and say 1, 2, 3, 4, 5, and 6, and cube each one of them. 1, 2, 3, 4, 5, 6, and square each one of these. 1, 2, 3, 4, 5, and 6, and just add these up. Okay. 1 to the power of 3 plus 2 to the power of 3 plus 3 to the power of 3. Oop. 1 to the power of 3 plus 2 to the power of 3. Okay, so with this we get 441. Plus 1 squared, 2 squared, 3 squared, 4 squared, and 5 squared, and 6 squared. Plus 91. 1, 2, 3, 4, 5, and 6. Plus 21. We're going to give us 553. There we go. And so this is the last of the brute force methods that we're going to be doing. We've seen a couple different tricks that we're going to use on the next set of questions where we can break them apart into individual summations. We can also pull out any sort of coefficients as long as we leave behind something. So we noticed that when I had just an I couldn't pull anything out. If I had just a 5, I couldn't pull anything out. But if I had a 5 and an I, or an N and an I could pull things out. So let's go ahead and jump off to some of these, where instead of using brute force, we're going to use some abbreviations. So with this, I'm looking at the sum of I equals 1 to 50 of the number 7. Now, this might perplex us for just a moment because we're saying, okay, if I is changing from 1 to 50, I don't see an I that I can change. That looks like I just have a number 7. Where does the I go? Well, this is saying I'm adding the number 7 50 times. So the shortcut is if I don't have the term being changed, if I'm changing an I and C has nothing to do with I just take the number of iterations, which in this case is going to be from 1 to 50. My N is going to be 50, and multiply it times the number. So this is going to be 7 times 50, which is going to give us 350. The same thing goes if I have a variable. If I have a variable x, which has nothing to do with I, I'm going to say, well, okay, let's take x and let's sum it 50 times. So this is going to be 50x. Easy enough. What happens if I do have the variable that needs to be changed? What happens if I have something like I, and I'm dealing with it from I from 1 to 50? Well, our first step is always to pull out our coefficient, so I know that that 1/2 can be pulled out. So 1/2 times the sum of 1 to 50 of I. And now the shortcut of summing 1 plus 2 plus 3 plus 4 plus 5 plus 6 all the way to 50 is I'm going to take this formula right here. I'm going to say 50 times 50 plus 1 all divided by 2. So let's see what that gets us. So 1/2 of my N in this case is going to be 50. And then I'm going to take 50 plus 1 all divided by 2. And so let's work this out. So I get this and I say, okay, 50 times 51 is going to give us that as our numerator. We're dividing by 2 and dividing by 2. So we're going to get a grand total of 637.5. Oh. And now that's a lot easier than saying, let's add 1/2 plus 1 plus 1.5 plus 2 plus 2.5 plus 3 all the way up until we get to 25. if I have multiple terms right here, let's go ahead and pull several factors in. So why don't you try number 17, knowing that all we do is when we finally isolate the summation of I, is we plug in this handy-dandy little formula. Pause the video and pause it when you're done and see how well you did. Okay. So what I'm looking at is I'm going to split this into two sums. So I have the sum of 2i, let's keep this in purple, why not, plus the sum of 3. I know this one, just like previous, is going to be 3 50 times. This one I can go ahead and pull out the 2, and I'm left with the sum of I. And the sum of I can be abbreviated. Let's see, 50 times 50 plus 1, all divided by 2. Okay. So this will give us, let's see, 50 times 51 plus 50 times 3. Gives me that. 50 times 3 is 150. Is 2,700. Oh. And so hopefully you did well. Now, just like with I, we actually have a shortcut for I squareds as well. If we have an I squared, the sum is going to be almost the same thing. I have an n times n plus 1, but I'm also going to multiply that times a 2n plus 1 and divide the whole thing by 6. So for number 19 and 21, I'm going to split this into the individual terms, which will be the sum of I equals 1 to 50 of I squared. And then we're going to subtract the sum of 1 to 50 of I. We split it up into 2. This one allows me to say, okay, I squared is going to be 50 times 50 plus 1 times 2 times 50 is 100 plus 1, all divided by 6. And from that, I'm going to subtract I, which is going to be 50 times 50 plus 1, all divided by 2. Let's see what we get with this one. Okay. So this is going to be 50 times 51 times 101 divided by 6. We get 42. Actually, let's keep this in purple. 42925, and we are subtracting 50 times 51 divided by 2, 1275, and so we get 42,925 minus 1275, 41,650. Awesome. And so again, now that you've seen one of these in action, pause the video on number 21, try it out, unpause it when you're done, and see how well you did. Okay? So what we see is that we're going to split this and move that coefficient out front. So I'm going to go ahead and immediately pull that 2 out front. And I know this is going to be the sum of 1 to 50 of I squared. And then I'm going to subtract the sum of I equals 1 to 50 of 5. Sum of I squared, let's see, that's 50 times 50 plus 1 times 2 times 50 plus 1, that is 101. For this, it's going to be 5 50 times. Let's see what we get on this. 50 times 51 times 101 times 2 divided by 6. We get 85,850 minus 250. Yep. So let's make that a negative. Let's add our 85,850. And we get a sum of 85,600. Awesome. And so again, the last little tidbit, the last little shortcut is going to be with an I cubed. This process works exactly the same, except for I cubed is going to be n squared times n plus 1 squared all over 4. So without further ado, why don't you try numbers 23 and numbers 25. Unpause the video, see how well you did. Okay, so with this, we're going to break this down into a 2 and a negative 1. We have the sum of I cubed and the sum of I squared. I cubed, let's see, it's going to be 50 squared. Let's see what. 50 squared times 51 squared all over 4. I squared is going to be 50 times 51 times 101 all over 6. Let's see what we get here. So for our first one, we have 50 squared times 51 squared divided by 4 times 2. We get 3,251,250 minus 50 times 51 times 101 divided by 6. 50 times 51 times 101 divided by 6. 42,925. We get a grand total of 3,251, 250 minus 42,925. $3,208,325. Awesome. And if you did the one with the n is almost the same setup. We're going to factor out the n, and we're going to leave this as the sum of 1 to 50 of I cubed, and because I factored out the n, that's just a 1. So plus the sum of 1 to 50 of a 1. Let's see, this is going to be 50 squared, 51 squared, plus 1 times 50. Let's see where we at with this one. 50 squared times 51 squared divided by 4. Let's see, we have 1,625,625 n plus 50n is 1,625,675 n. And there we go.